read his books or research articles too.
So Bjarne talked about the splinters. Here's a graphical representation of the splinters. Bjarne and I started at, with Bell Labs at AT&T, and the representation here is a little misleading because it indicates that things get bigger as you go along. In fact, we started with a company that had 1 million employees, and Avaya now has about 18,000, so smaller and smaller pieces. What I want to talk to you about is work that we've been doing within Avaya on software quality. When we built up the research program, the focus was, or the guiding principle that we used was improve the state of software in the company and know it. The know it part is particularly important because there's a lot of data that we collected, and there are annual state of software in the company reports that we've been publishing. Much of the information about the reports and what we do in software is specific to the company, so I'm not sure that that would be of general interest, but I am going to talk to you about the methodology we've been using, and starting with a view of, so here's the outline, starting with the notion of what is software quality, how do you measure it, and then what do you do to improve it. The fact is that I'm sure all of you have dealt with software, and I'd like to have a show of hands for somebody who's dealt with a piece of software that doesn't have any bugs. Hey, look at that!
Once.
We do have one. Well, for the rest of us, the question comes up about how we define software. Just to give you some perspective, in Avaya, there are about, in the last 3 years, and state about, each year it's, this data is a couple of years old, but we have about 100 million lines of code that have been touched in the last 3 years. The amount of code has been growing dramatically, and it's been growing because Avaya is a communications company, and as we move to new modes of communication, you go from voice to video, web sharing, all sorts of things, the amount of code has continued to grow. And I wanted to provide that as a perspective for the scale of things that we've been dealing with. Starting out with, just a couple of disclaimers. The disclaimers are that, in particular, comparisons across companies, the general trends are the same, but the specific numbers may not carry over. And we find that even within the company, because there are different divisions. In fact, if all we could do was to take the best performing projects and take those techniques and have them be used uniformly across the company, it would actually improve things tremendously. So some of the issue with software quality is just making sure that the scale and that the techniques get used across the company. So starting off with the kind of data that we've been collecting, part of the goal of collecting the data has been there are 3 main systems. So first is looking at what's available. The questions that we want to answer may not necessarily match up with the data that's available, and that's where the creativity comes in to say, how do you take the information that's available and extract from it what you'd really like to know. So we have problem tracking systems, so bug reports, who made changes, version control systems, and also directories, because over a decade or so, there are cases where people who wrote the original software have left, and through the directories we can actually track things. We've also been tracking who the customers are, what do they have deployed, how many releases do they have, because there's a lot of software out there, and when a bug report comes in, it's finding out, being able to track down and have some sense of where it fits. So there's a fair amount of data that we've been collecting. In fact, research actually has a better view of data across the company than any one part of the company, because they focus on their own piece, and we've been looking across the company. Let me begin with the notion of quality, and we're going to start with quality that is post-release. So what happens when the software gets out to customers? Keeping in mind that it's not just that there is a bug in the program. It may be that the software didn't get configured properly. The software has to be installed. Our customers tend to be large companies that, almost all the Fortune 500 use our systems, and they are across the world. There are different business partners who may be doing an installation in another country. Avaya has employees in 54 countries, but there are many other countries that our customers operate in. And so configuration and things like that can be an issue also in software quality. So that said, let me start by saying one of the things that we've settled on is a notion of software quality and a particular set of metrics that I'm going to introduce to you. Starting out with simply what are the number of defects, or what is the defect density even, does not actually give you a sense of the quality of a piece of software. The reason is that the number of defect reports or the number of customer found defects actually tracks the number of installations rather than the quality of the system. So on the x-axis, there are each unit is tens of thousands of systems, so it's going from 0 to about 70,000. And along the y-axis, you have customer found defects. And as you can see, that there is a pretty linear correlation there between the number of defects that have been found and the number of systems that have been installed. So what we have been doing, instead of using simply the number of customer found defects, it's starting to look at the ratio of defects to the number of systems that have been installed. And there again, there are issues. So we've settled on, or we found most useful to look at the number of systems that have been affected, because the issues you run into is you may have many bugs reported, but the same system is affected. Or you may have a few bugs reported, but they're spread across different systems. I will actually have an illustration of this. And from taking a perspective from a customer's perspective, they don't care about the number of bugs. They care about whether their system is up or not. And because of that, we've been looking at the number of affected systems and taking the ratio of the affected systems to the number of systems that have been installed. There's a subtlety I'll come to in just a minute, but roughly we're taking a ratio. And if you take a ratio, then you find that the number of, this is the same data as from the previous chart, and in the previous chart we had the number, the curve going steadily upward, and here you find that the systems that actually have a lot of, where there are a lot of installations, the ratio is actually lower. We've also found that as the number of releases increases, the ratio tends to drop, and so you see the gray curve and the orange curve. What's not shown on this chart is that as you go from the 4th to the 5th release, it turns out that the number of bugs or the density actually goes up. And the reason why it goes up is that initially you have a set of functionality that's been delivered. People, not only are errors eliminated, but the people who are doing the installation have learned how to work around any issues that there might be with the system. And as you get to the 4th or 5th release, there's new functionality that gets introduced. And so the curve shown coming down here actually curves up a little bit and goes down. Okay? So we've gone from looking at the number of customer found defects and then taking the ratio of affected systems. Here is the actual metric that we've been using. You also have to limit the number of the time interval. And we're limiting the time interval because in order to do true comparisons, you may have one system that's been in the field for, say, 6 months, and you may have another system that's been in the field for several years. How do you compare across those systems? And so the way the metric is set up is we've been looking at 1 month, 3 month, and 6 month intervals. Roughly 6 months because you end up with subsequent releases. So looking beyond 6 months has not provided further insights. So the idea is you look at the number of so you take the number of affected systems, take that fraction, and consider the trouble tickets in the time from when the system is first installed. The 3 metrics are useful, the 1 month, 3 month, and 6 month. They're useful because the 1 month metric actually gives you some idea of what the initial issues might be, and the feedback that comes from there is if the 1 month metric is high, that means you have to train the people who are doing the installation. If the other metrics are high, that means that there are more residual issues in the system itself, and those have to be affected. So here are 3 examples. GA is general availability of the system, and we look in the, say, a period of time. In the illustration here, it's looking at, so a product becomes generally available. You look in the 7 months from the time that the product becomes available. And then you look at the systems that have been installed there. And for each system, from the time it's installed, you look at the issues that may have occurred in a fixed period, which is either the 1 month, the 3 month, or the 6 month interval. So system 1, which was installed shortly after GA, there are n months that gets considered. System 2 is considered even though it was installed late in the 7 month period. But system 3, which was installed later, we don't consider in order to do proper comparisons. And over time, this metric, the CQ metric, has been the customer quality metric, has been used within the company, and it's gotten to the point where it's being used to drive decisions that have been made. The next step, which I do not have illustrations for, what we're looking at is, all right, so now that we have a metric for what happens post-release, now let's see what are the predictors. And so we've been looking at things like people doing static analysis, architecture reviews, development processes, and doing measures there, coming up with metrics there, which would be predictors of what the quality is going to be in the future when the system is installed. Okay, so this has been a key metric. So anyway, the illustration I was giving you was, here are two systems, P and Q. P had few affected systems. So there were 45 customer-found defects, and they affected 26 systems. Q, there were fewer customer-found defects. There were more systems that were installed. But when you take the ratio, you're looking at the because you're looking at the number of affected systems as opposed to the number of bugs, the Q, which had fewer customer-found defects, ends up with a higher ratio than the other one. They're both within statistical bounds, but anyway, that's what we've been using, and that's an illustration of the actual customer quality metric. Okay, another issue that we've been dealing with is the fact that the systems have become more complex, and as the complexity increases, as the number of different releases, so you end up with many different products being put together into an overall solution. We've ended up with as many as 30 different product types that are needed in order to implement a system for a company. As that increases, the number of escalations or issues that come up increases non-linearly. So we've been using a model internally, and starting off, and this is a model where the idea is to get a handle on the overall solution as opposed to a given product. So we start off with capturing what the customer usage is, and then connecting that into, let me actually use a diagram to help you with this. So it's starting out at the top with how is the solution going to be used? What are the things that are important to the customers? What kinds of scenarios will they be deploying mostly? Based on that, there are, or that ends up guiding the reference configurations. These are reference configurations where there's an extensive amount, they are tested more than others. You cannot actually test everything, and so there are certain configurations where if those get deployed, you're less likely to end up with having issues. And those end up driving back the guidelines. So you may have a product that was designed to be used for, say, 3,000 endpoints, and somebody's deployed it in a setting where there are 20,000 endpoints. You're going to end up with an issue as a result of it. So, so by using this model and setting up the feedback loop, what we've actually been doing is looking at specific customers when there are issues, mapping them and saying, where did the issues arise? Was the system sold into a setting where it wasn't designed? That would be with respect to the engineering guidelines. Was the configuration a non-standard one? Customers to end up wanting something special. And then what are the, so anyway, there are feedback loops that have been put in place, and the model has been helpful to us. I'll give you just a little bit of how the practices have changed. So in the years that we've been tracking, we've been doing, as I said, the initial up front, the goal was to improve the state of software and know it. This relies on hard data that we can get of, say, the number of escalations, which I was talking about, but also interviews with groups, and it's very structured. There are structured interviews that are conducted on an annual basis. There are reports that get published, and what you see in this curve is the trajectory of one class of practices which are roughly under the category of designing quality into the system. Along the x-axis is how widely is this practice used. Along the y-axis is and how effective is it. You may have something that's used very widely but it's not effective, in which case you need to find something else. Anyway, so this is design quality in, as you can see, test automation. Everybody knows you need to do test automation, but you know, how much is it used? Not as much as we would like. Customer-focused development, architecture-guided iterative development. Cross-project cooperation continues to be something that's getting better, but we have a long way to go. Doing a fair amount of multi-site offshore development. We've done, reduced a little bit of it, but the effectiveness has gone up. And then project management, that's been good. Something that we found as far as the learning curve goes, it actually takes 3 years. If you move a project from one site to another, it can be within the US, it could be from one country to another. It actually takes about 3 years for people to come up to speed where they can mentor each other. And this is based on data that we've been using of how long it takes people to resolve MRs and things like that. So that was interesting. And let me get us back on time. I thought I would end with a French postcard from 1910, and this was their view of what video telephony would look like in the 21st century. So even though the technology has changed somewhat, people's desire to communicate has been there all along. So with that, I'm happy to take a question or two if we have time. Okay, question.
You said that test automation isn't used very broadly. Do you have an idea, in general, how many places do use test automation?
So it's actually quite varied within the company. What we've been doing is tracking how different projects use it and how effective they've been. And as this data gets published, more groups have been doing it. So test automation is very important because one of the issues that comes up is you have a bug, you go fix it, and in the process you break something else. And if you haven't automated your tests, then people are very hesitant to go make any changes because they are afraid of introducing breakage. The groups that have done test automation tend to have less breakage. And so that's why it's increasing. Question?
So something like a web system where you have basically a lot of users and just one server or several servers in your study, will it be like one system or multiple systems?
So what we've been looking at is that would be one system because we're looking at say a customer, they have multiple sites. At the sites they have different systems installed. Once you run up into an issue of various sites being affected, you know, that gets into some of the how things got reported, how the trouble tickets were handled, and that's partly why I was saying the data isn't comparable from one company to another, because it depends on exactly how things get measured.
Bjarne. So for testing a distributed system, you actually test a distributed system, or do you put different versions of the system in a single room and then imitate failures or delays?
So there are several levels of testing. One, there's the testing at the unit level, and then there are test labs, and we also have a systems interoperability lab where they do it in one location, but they have systems from other companies, and so it's not just looking at our own products. It's looking at what a customer's configuration might be. And then our services folks, before they go in and do a complex installation, will actually at times simulate what the customer's multi-site arrangement would be, so that when they go to do the installation, the people who are doing the installation have some experience with it.
Okay, I think we should stay on time at least for the first talk, so we say thank you.